Hello, hello. All right. So, my class always asks me, my students are always like, Miss, make a YouTube video. So, even though there's like 5,000 of them already out there, I am going to make a video for you all to help support while I'm teaching this semester. So, we're going to go over the beginning algebra book. This is the book I'm using. I don't know what all that noise is. There was like no noise when I started this. So, as you all know, hi, my name is Nickie Ray, Miss Nickie, whatever you want to do. And like I said, I'm making a video going over beginning algebra concepts, all right? So, everybody told me I don't have to do nothing fancy, just hit record. So, I'm hitting record. Are we ready? So, let us begin with a review. What is that? Review of pre-algebra, right? So we're going to go over some terminology real quick. I want to make sure that we are all on the same page as we get it started. Okay. So, first set says integers. We know integers are regular numbers, but they're regular numbers with signs. So they're sign numbers. So when you have a number 4, we know the value of 4 is 4. If you add a negative to it or a positive to it, we now take it from a number to an integer, okay? So integers are signed numbers. And so you guys will see a lot, I'll probably not say numbers too often, I'll say values, because I want to be sure that we're including variables, right? The letters, we'll get to variables in just a minute, but right now, you just need to know that integers are signed numbers. So if you see the word integer, you're talking about a number with a sign on it, okay? And of course, if we see positive, that means you have a good value. That means like you have money in your pocket, right? Positive and negative, where does that come from? It comes from the number line, right? Number lines were designed to talk about location and where something is. So your number line is always split, right? Because here is 0. This is like our negative side when you owe some money or your account's in the red. And this is your positive side. So as you move further to the right, your values increase. They are positive. After you go to further left, you hit 0. That means you have no money in your pocket. It's like how the credit cards will let you spend money that you don't have, but then they charge you that, or your bank will sometimes like cover a charge that you have even though you don't have enough. Maybe you tried to buy something for $32 and you only had 25. So that's all that. That's the same thing. The same type of negative. Numbers do not ever end. They go on indefinitely, right? So forever. You can't stop counting. Forever left, forever right. Okay? And we have, like I said, the opposites. When we talk about integers and signed numbers, you want to recognize opposites or inverse opposites. So if we have a positive 9, the inverse or the opposite of positive 9 is going to be negative 9. We're going to go call them additive inverses because we're going to use this often as we progress in simplifying expressions and solving equations. So additive inverse means opposite, right? So again, additive inverse of negative 10 is going to equal 0. So anytime you add some inverse values, it's going to equal 0. 0 is what we use when we cancel out something, not when we reduce out. If we end up with a 1, that means we didn't cancel it because we still have 1. But if we have a 0, then it canceled out. So additive inverses will cancel out and make a 0. other terminology. Oh, absolute value. That's a very important one. I'm going to leave the number line. Actually, I'm going to move the number line up. I wonder, can you all see the green ink? Because I love colors. I love to teach in color. Can you see that? Oh, yeah. Okay. So I'm going to put the number line up there. Getting a little crazy with my board. All right. 0 again. We know this is our positive. This is our negative. So when we're talking about absolute value, right? Absolute values should be defined as the distance from 0, right? From this 0 right here. So let's just say we're going further down our negative on the number line, and we're way out here, and this value, and this value that we've selected is negative 14. Well, can you still see that? I can't see that 14. My blue's getting a little blue, apparently. It don't want to work. So let's try this one. We're going to do negative 14. Okay, so the absolute value of negative 14, if we apply the definition, what is the distance from 0 that negative 14 is? Well, that means I have to move 14 spaces on the negative side to get to negative 14, right? So again, absolute value is going to be our distance from 0. Our distance is never negative. You can't travel negative 200 miles. You know, you don't walk negative 200 feet or anything like that. So absolute value is always your distance from 0. I know before you probably learned that absolute value is always positive. Well, again, that's because distance in measurement can't be negative. But let me show you. Let me show you the notation for absolute value as well. These are called absolute value bars. These bars right here, this symbol, because this is part of what makes math universal, right? You have to know the definitions of what your symbols mean. These two bars are called absolute value bars. And we want to know what is the absolute value of negative 14, which we talked about. That means we move 14 spaces from 0. But again, the reason I don't want you to stick with, ooh, it's always positive, is because if there's a negative out here, then that means I'm asking for the negative of the absolute value of negative 14. And so as we go through, we know that we have to simplify step by step. We always follow our order of operations. You'll recognize we're going to evaluate this first. We know that that's 14, and then we'll just bring down our negative. We don't ever leave things, right? Never leave things out. We can't just say, oh, that means it's 14. No, what happened to this negative? And we'll get to why there's an understood value, because you can't just have a floating sign, right? We don't have a floating positive or a floating negative. If your values don't have a sign, we know that they're automatically positive. We don't have to always add the positive symbol. But we won't ever just have a floating negative by itself either. That means there's this understood one in front of it. But again, that comes later. Right now we're talking about absolute value. Absolute value is, what did I tell you the definition was? Distance from 0. All right. So that covers those first vocabulary terms we have in there. And then it wants to move on to adding or operations with integers, right? Let's see what we got here. Ooh, we looked at representing values on a number line. Okay. Here's some practice. If you want some practice, you can read through that. And then now, put my marker down. We're going to move on to over here. Operations on integers. Okay, and you see that little thing down there, that multiplication and division? I have a very nice Nice tool for you to use for that. Here's some practice questions if you want to get started on some practice questions, because you already know what's going on. Okay. Operations with integers. I think I'm going to start with a summary of it for you, and then we'll go over the steps. I'll leave my number line up there. The cool thing about math is that rules do not ever change in math. It doesn't matter what level of math you've gotten to. If you're in calculus 3, if you're in differential equations, in discrete math, or you're still down here in developmental math. Developmental being not that you're slow up here, but how these big concepts in calculus get developed, and in trigonometry and all that. So, but the point is that rules don't ever change, ever, 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 ever. So even if I hadn't taken calculus 3, I could be pretty successful in it, because as long as I followed math rules, they don't ever change, right? So when we talk about operations with integers, what are integers? If I misspell something, you guys, I'm not a spelling teacher. What are integers again? Signed numbers, right? So when we talk about operations with integers, we got to recognize that there's only 4 mathematical operations that you do. Even in all that fancy math we were talking about, there's still only 4 mathematical operations that you do. You're either going to add and subtract, or you're going to multiply or divide. I wrote them out like this because these two are inverse of each other. What does inverse mean? Opposite. These two are inverse of each other, and these two are inverse of each other. So inverse meaning opposite, like we said. One is tying your shoe, untying your shoe. Drinking a glass of water, or filling a glass of water, you drink the glass of water. They're opposites. Turn the light on, turn the light off. Open the door, close the door. One doesn't exist without the other. The definition of subtraction is the inverse of addition. The definition of division is the inverse of multiplication, right? And we know multiplication is quick addition. All right, so let's talk about adding and subtracting integers right now. Let me make some more space. My little camera, I don't know how much you can see, so I don't know how much of the board we have right here. That's why I'm sticking right here. I don't know what else you can see. So, but operations with integers. So let's talk about adding and subtracting integers. All right, so the quick summary is when adding and subtracting integers, if the sign are the same, we add the values and carry over the sign, or keep the sign. So what that means is, let's just say that we have a 4, and remember, you can't see the 4, or I can't see the 4 on my screen. Let me see, there we go. If we have 4, and this 4 written here, you don't see a plus or a minus in front of it, right? So we know that this is a positive 4. And then if we say minus 6, let me not do that yet. I'm gonna say plus 6. Okay? The signs are the same. We add the values and we keep the sign. So this is a positive 4 and a positive 6. So that's gonna equal a positive 10. Okay? We had negative 3 minus 5. Again, the signs are the same because my value for my 3 is negative. My value for my 5 is negative. 5 and 3 is 8. and I'm going to keep the sign. So that makes it -8. Okay? So the same thing, like I said, same signs, we add and we keep the sign. When our values are different, let's move over to this side of the board now. Oh, got stuff over there too. See, this is what happens in the class. I be having stuff everywhere. Okay. When we have different signs, how's the green look? Okay. Different signs, we subtract our values and apply the sign, subtract the values, and I wanted to say apply the sign of the largest number. So subtract the values and then apply into that answer. That's what I'm missing. Did y'all hear that? And to that answer, apply the sign of the largest value. Can y'all see all that? Can you see all that? You see it pretty well? Okay, I can see it in the camera. So I hope you can see it if I can see it. All right, so what does all this mean? What did I mean when I said that? If my signs are different, we're gonna subtract our values, and to that answer that we get from subtracting the values, that difference, the answer to subtracting is called a difference. To that difference, we're gonna apply the sign of the biggest value. What that means is, I was gonna write it by the number line, but I wanna change from the green. What that means is, let's just say we have a -6. I don't know what happens in my marker. Can you see that? I can't see that in the camera. Can y'all see that in the camera? I think there's a reflection of my little ring light on there. Yeah. And I think my brown wasn't acting right. Let me see if I move it. What's a good spot? Over here? Okay, let's try over here and see. Oh, there's another reflection. Let's go above the number line for this one, okay? So we're gonna say -6. Can you see up there? Okay. -6, we're gonna say +8, right? So our 6 is negative and our 8 is positive, because your sign is always gonna be in front of your value. A value can only have either a positive or a negative. It can't be both. And so you can only have one sign. So you'll see something like this, but we'll talk about that in a second. That means this 8 is positive. This won't, you shouldn't see all 3 signs together. You'll see 2 signs together, but you won't see 3 signs together. And no matter how many signs you see, we know that this 8 is positive because it's the sign right before the 8, right before the number. So anyway, different signs, we're gonna subtract the values, right? Different signs, we're gonna subtract the values, and to that answer, we're gonna apply the sign of the largest value. So I'm gonna come back over here, -6 and 8. So I'm gonna subtract. 8 minus 6 is 2. And when I look, what value is biggest? The 8 is, so my answer is a +2. Make sense? If I had 14 minus 24, right? So again, I know my 14 is positive, even though I don't see a sign, I don't see a negative, so that means it's positive. And 14 minus 24, this one is negative. Positive and negative means I have different signs, so I'm gonna subtract my values. 24 minus 14 is 10, and 24 is bigger than 14, and that's negative, so my answer is -10. Is that making sense? Hopefully it does. If not, when I finally post this on YouTube, drop it in some comments in there and we'll see what's up. Okay? This is my first time. Bear with me. I'm reluctantly doing this only because I love math so much. Am I standing in front of information? So that is adding and subtracting integers, right? Again, if the signs are the same, we're going to add our values and apply the positive or apply whatever sign the values have. If our signs are the same, we add the values, keep the sign, right? If our values are different, the sign of our values are different, we subtract our values, and the difference gets the sign of the largest number. That is for adding and subtracting integers only. Now let's talk about multiplying and dividing integers. This down. This is cool, right? Because then, like, if you didn't see something or I was blocking it, you can like pause it and go back. It's pretty cool. Pretty cool idea. We'll see how the video comes out. I'm not editing the video, you guys. So if it don't come out good and you don't like it, just don't watch it. I'm sorry. I'm just saying. Yeah. Okay. Let's do multiplying and dividing integers. Can y'all see that? Barely, huh? I don't know what's up with my markers. They keep coming to jack my markers. I don't know. Anyway, now the rule for multiplying and dividing integers, once I show it to you, it's going to be a little bit easier. It's easier to remember. You might not implement it as easy, but you should. You should. So I'm going to go first to the shortcut, what I'm talking about, okay? And it says here in the book, it tells you all about it. Look. All right. To multiply and divide integers, it says do all this. It has a great explanation, right? Okay. Well, I'm going to summarize what that says. You ready? This is what we do for multiplying and dividing integers. You've probably seen this before. One of my students showed me this a long time ago. What do y'all call that? A hashtag? I still call it a tic-tac-toe. Make a tic-tac-toe. Diagonal pluses, right? Give yourself diagonal pluses, and then fill the rest of it in with minuses, right? Positives and negatives. Fill the rest in with negatives. Now, any way you read this, be it left to right, right to left, top to bottom, or bottom to top, this mimics the rules for multiplying and dividing integers, because a positive times a negative will be a negative value. A negative times a positive, the same thing, positive times a negative, negative times a positive, will be a negative value. But a negative times a negative will be a positive, right? And a positive times a positive will always be positive because it's positive. But and I guess you could do that. Positive times positive is a positive. It's the only one you can read diagonally. This mimics your rules for multiplying and dividing. So if you forget, if you're like, oh, wait, what is a negative divided by a negative? It's a positive. What's a positive divided by a negative? A negative. So what does that mean? That means if I have positive 10 and I'm dividing it by negative 2, a positive value divided by a negative value means my answer is going to be what? A negative 5, right? And the cool thing about fractions in these rules, right? Fractions are awesome because they represent division, right? And they always hold true because you can always multiply your denominator times your whole number and you'll get your numerator every single time with every single fraction, no matter what level of math you're in, no matter what you're doing. If you actually do the division, because that's what fractions represent, division, and you use them all the time. If you say, oh, I'll be there in a minute, or I'm almost there, or if you're like halfway, or in a few, or a quarter till, anything like that, you're using fractions, okay? Wait till we do a fraction story, it's fun. So anyway, a positive divided by a negative will be a negative. If I had a negative divided by a negative, my answer is going to be a positive, right? What's a negative divided by a negative? It's a positive. What's a positive divided by a negative? A negative, right? And we have it shown two different ways, just so you know. There's fraction form, and then there's division form, same thing. All right, so we got a positive divided by a negative is a positive. Negative divided by a negative is a positive. I'm sorry. Positive divided by a negative is a negative. Y'all see this negative right here. And then a negative divided by a negative is positive. Okay, so the book says to use their absolute values and stuff, which we've already gone over what absolute value is, but everything that it says is the same thing as this right here. And so that's what you'll notice. Whatever book you're using, whatever resources you're using, you should recognize that we're all saying these things differently. We're all telling you to go to Fair Park, but we're all just giving you different directions, okay? That's all that is. That should help you, just to let you know that what you read, it shouldn't be as confusing. And so it goes on in the practice to talk about grouping your values together. But I want to go over one more. I was just looking to see what it was, because I really want to just go over exponents with you for right now. I don't want the video to be too long for you. I want you to just get a gist, open up, kind of see where we're going, what we're doing, and we'll talk about that, okay? So, exponents. Exponents. Let's talk about exponents. You know what exponents are? We've seen them before all the time, right? Those little bitty numbers at the top right-hand corner of a value, you'll have a value, and then there'll be another little number next to it, like you might have 5. And then there's 3 at the top right. Well, the 3, that's the part that we call the exponent, right? Exponent. And the 5 in this situation, that would be the base. That's what your exponent is attached to. And so what the exponent does is it says, I want you to multiply the base times itself exponent amount of times. So does that mean I'm going to do, what's our base? Before I tell you, the base is what? It is 5. The exponent is 3. So according to what I just told you, the exponent says multiply the base times itself exponent amount of times, right? So my base is 5 and my exponent is 3. That means 5 times 5 times 5, right? And then you just evaluate. Evaluate means to give the value. 25 times 5. And how much is 5 quarters? If you have 5 quarters, you have $1.25, right? So you, as you go through your math, you will come across and see different things. Remember that rules do not ever change, okay? And I know we haven't spoken about variables yet, but again, variables take the place of numbers, of values. They're unknown values at that time. And so unknown values are something like grapes. Take grapes, right? I don't know how much grapes are at Tom Thumb. I don't know how much grapes are at Walmart. I don't know how much grapes are at Aldi. I don't know how much grapes are at Kroger. So what I would do, I said Tom Thumb, right? So grapes at Tom Thumb, that the value of those grapes could be represented by a T. The value of the grapes for Aldi would be represented by an A. The value of grapes at Kroger could be represented by a K. The value of grapes at Walmart would be represented with a W. Because again, we don't know what these values are. Oh, I was like, oh my God, have I been doing this the whole time and I'm not recording? Yeah, gotta work with me, I'm a little goofy. We don't know what those values are, but it doesn't mean that we still can't budget or work around them, right? So we'll get into variables soon. But you will see an occasion where you have an X or any other variable, because you could choose any of the 26 letters of the alphabet. So X, and you might see it raised to the second power. Or you could have, well, let's leave that there. You could have A to the fourth power. Or you could have N to the ninth power. You could have any of these. When you get to college algebra, you'll see I to the 243 power. Rules don't ever change, okay? They do not ever change at all in math. In math, let me clarify, in math. There was no new math. There was a new way of explaining it, but there hasn't been any new math, okay? So that's what your exponents are. That's how we handle an exponent. This is raised to the third power. We always evaluate. So now we get down to that one thing that everybody always talks about. P.E.M.D.A.S. Right? What is P.E.M.D.A.S? P.E.M.D.A.S is actually just an acronym to help you remember the hierarchy in which you perform your mathematical operations. I'm like, what? That's some fancy words. Yeah, I know. That's what it is. But it really is, P.E.M.D.A.S is an acronym to help you remember the hierarchy of your mathematical operations. What do I do first? When I come across a situation that says something like 28 divided by, oh gosh, I just looked down, so I'm copying this little example they have here. Not this, well, it is an example. I'm going to say times 2 minus 12 divided by 3 plus, looks good, right? Don't panic, you got this. Negative 5 squared. Dang, is that the whole thing? Okay. Can you see all that? Negative 5 squared, yeah, you can. I can. Okay. So again, P.E.M.D.A.S is just an acronym to help you remember the hierarchy of mathematical operations. Basically, that means which operation do I do first when I have an expression, not an equation because there's no equal sign, when I have an expression that has so much to do, that has all of my mathematical operations involved in it. How am I supposed to know where to start? How do I know what to do? That's where P.E.M.D.A.S comes into play. And since I told you it was an acronym, P represents parentheses. P-A-R-E-N. So when we say P represents parentheses, that's parentheses and all other grouping symbols. And all other grouping symbols. So grouping symbols are, obviously things that will show you that these values are together. So excluding, we know parentheses, right? One of them's leaning a little bit, it's okay. Besides parentheses, and then I drew it back and it looks the same, right? It's okay. So besides our parentheses, we also have brackets. Those are grouping symbols. A fraction bar, that's a grouping symbol because it wants you to evaluate everything in the numerator before it does everything in the denominator. We have absolute value bars because you could be at the absolute value of something other than just one number. We have a radicand, which is what you use for like square roots and stuff, right? That also is a grouping symbol. What else do we have for grouping symbols? Parentheses, brackets, fraction bar, radicand, absolute value. I can't think right now for some reason. I got a little distracted. But What's that little plus doing? Let me move that so y'all can see it a little bit better. I see a light reflection in there. So I'm gonna move my fraction bar over here. And then I'm gonna move my absolute value bars over here. Right? But all of those are grouping symbols. So when we say P for parentheses in this acronym PEMDAS, we mean parentheses and all other grouping symbols. I guess GEMDAS just didn't sound good. I don't know. So the P means that we will first evaluate everything in the parentheses. The E, what do you think that represents? Exponents, right? So the E represents exponents. So first we go through and we look for all grouping symbols. Then the second thing we do, we're gonna look for any exponents that we have. And then we'll evaluate those. So here's the part where that gets a little mixed up, right? Because you have these two. And I usually put it like so, so we know. The M and the D represent multiplication and division, but those are done in order of left to right. So what that means is that just because the M is written first, we do not necessarily just do multiplication first. No. We do multiplication or division, whichever one comes first. So as we look through here, right here, when we get ready to get to the M-D part of it, we recognize this comes first. So we will do this before we evaluate this multiplication, okay? So done in order left to right, multiplication and division. And then of course now the AS, you know what that represents. Can you see right here? That is addition and subtraction. And that also is done in order of left to right. Right? So again, we will not just skip this subtraction or this subtraction because we have addition first. Both multiplication and division and addition and subtraction are done in order left to right. That means the first one you see is the first one that's evaluated when it comes time to do that. Does that make sense? First one you see as you go through. So your math in general, just like your number line, is read from left to right. Just like you read a book, everything pretty much is left to right, right? So we always want to start with the left and come over to the right, just like you're going to go from negative infinity to positive infinity. And that's how you typically say that, because that's what we do, left to right. So I'm going to go ahead and attempt to knock out this example we put up here that they gave us in the book. And we're going to follow our order of operations, and we're going to utilize our grouping symbols and everything else up here that we see to help us evaluate that first question, okay? So I'm going to erase all this, but again, you're on video, so you can stop it if you need to. Hope you guys like this. I don't know. We'll see how it goes. Oops. I need that back, right? What was it? It was 28. And then it said divided by. All right. So we went through our order of operations. I just dropped a marker. Okay. Following our order of operations, let us begin. And notice it did not give us an equals, so we will not put an equals on there. The difference between, if you're given an equals, then you actually have an equation. Whereas if you don't have an equals, you have an expression. So an expression like, hey, how you doing? Well, that's a whole question, but hey, hi, huh? Those are just expressions. So, but we don't have any equations, there are no equal. So we always work it down, right? And you do one evaluation per line change. So as we go through this, we're going to follow our order of operations. We're going to start with parentheses. And when we talk about these parentheses and these grouping symbols, we're looking for work to do. We're looking for some evaluation to perform, right? So over here right now, these parentheses are just holding this -5. There's nothing to evaluate inside the parentheses. However, we have something to evaluate here inside these parentheses. We see these parentheses are just holding that +2. Second job of parentheses, other than holding things, parentheses represent multiplication. Oh, I think you remember that, but just in case, yes, the parentheses will represent multiplication as well. But as far as evaluating this, and like I said, one change per line, we're going to start and read what we have. We have 28 divided by 4 minus 8 times 2 minus 12 divided by 3 plus -5 squared. Did you catch that? 28 is divided by 4 minus 8 times 2 minus 12 divided by 3 plus -5 squared. So we look, parentheses. Where do we see some evaluation? Right there, right? So we bring everything else down. We don't want to make mistakes, and we can't just leave things off. Like leaving things off is the same thing as cutting a 0 out of a magazine and taping it on a dollar bill. Okay, we just don't do things like that, right? We can't just up and change things and just figure it works. So 28, we'll bring that down because we're not going to do anything. We are going to evaluate this 4 minus 8, so we bring down our division. And what is 4 minus 8? Well, we see we have integers, right? We know our 4 is positive because there's no sign. Our 8 is negative. That means our signs are different. When our signs are different, we're going to subtract our values and keep the sign of the largest number. Subtracting our values, 8 minus 4 is 4. 8 is bigger, so my answer is -4. I still have my parentheses. I'm going to bring down my 2 and bring down everything else. 12 divided by 3 plus -5 squared. Cool. Did that. Parentheses. There's still more parentheses, but is there anything to evaluate? Now there's no evaluation needed in that. So again, I know my parentheses are representing multiplication. No evaluation needed in that one. They're representing multiplication. No evaluation needed in that. That represents multiplication. So I'm done with my parentheses. Now I move on to my exponents. I don't have anything with an exponent until I get here, right? Because this 2 is applied to the -5 inside. Okay. And remember, you have grouping symbols, so if there was something to evaluate in there, that 2 would apply to everything in there. But our order of operations says we get to evaluate it first, right? So right here, I have a -5 2 times, and I know -5 is my base, and I know 2 is my exponent. So that means I'm going to multiply my base times itself just 2 times. That means -5 times -5. And then if I draw my little tic-tac-toe to help me, because sometimes I forget, I know I need positive diagonals. And then I can say a negative times a negative is a positive. Negative times negative is a positive. Cool. That should stay on the side of your paper, right? We'll keep that over there to help me remember it. So 5 times 5 is 25. Negative times negative. There we go. 5 times 5 is 25. And a negative times a negative is a positive value, right? So I'm going to write everything down again. 28 divided by, this is -4, times 2 minus 12 divided by 3. Kind of talking it out to myself so my mind can start knowing what's there, what I'm getting ready to do. Think about the rules that I need to help evaluate this. And I'm going to say plus now. And what did I get? A positive 25. All right, so I've done my parentheses because these are just holding now. I've done my exponents, and now I need to look for multiplication and division in order of left to right. So again, I'm not just going to hop here and multiply. No, no, no. I have division first, correct? Don't I? Yes, I do. So I'm going to go ahead and do my 28 divided by -4. Dang it. I need my little cheat thing again, right? I'm going to put it over here this time. And put it right here. Can we see? Put it up here. Positive, positive, positive. Negative, 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 negative. Right? So I left that on my paper now. I put that, oh, you can't see it. It's in the little heart sparkle thing. Heart reflection. Let's see if I can put it up here to help me remember. Draw a tic-tac-toe. Do positive, positive, positive. Fill the rest with negatives. Okay. Got it. So now, 28 divided by -4. My 28 is what? My 28 is positive. I have a positive divided by a negative value. I know that these two need to be multiplied, but my order of operations say I do multiplication and division in the order that I see first. Whatever I see, first come, first served. First come, first evaluated, right? And it says 28 divided by is the first. Always read your math. Read it, read it, read it. You'll hear me say that a million times. 28 divided by 4. So how many times does 4 fit into 28? 28 is positive, 4 is negative. So a positive, can we see that? A positive divided by a negative is going to be a negative value. So I have -7. Now bring everything else down, times 2, minus 12 divided by 3 plus 25. Now if you want to keep your -7 in parentheses, you can. You do not have to. Again, we know the parentheses were only holding something, okay? So now, left to right, I have a -7 times 2 minus 12 divided by 3 plus 25. Again, I'm still working on multiplication and division from left to right, but notice I'm only doing one evaluation per line to make sure I don't miss anything and I can see everything that's going on. So a negative times a positive, a negative, there it is, negative times a positive is a negative. 7 times 2, -14. I'm going to bring everything else down. 12 divided by 3 plus 25. I'm like, okay, now I just have -14 minus 12 divided by 3 plus 25. Minus division plus. Got to do this one next, right? Multiplication and division first, then addition and subtraction. Let me bring down my -14. And I know I have -12 divided by 3. Since there's no sign in front of my 3, I know my 3 is positive. So negative divided by a positive, negative divided by a positive, it's a negative answer. 12 divided by 3 is, okay, -4 plus 25. And now this part, again, we are just coming to adding and subtracting. So I like to do my adding and subtracting as if I was on a number line, right? But these are big numbers. I don't have a number line out there. So, of course, you would just do these two first. -14 minus 4. So we can picture ourselves. Let's see if this helps you a little bit. When it comes to adding and subtracting integers, right? Another way to do that is to picture yourself moving along a number line, right? Because no matter where you start on the number line, this is always your negative, and this is always your positive. Can you see? There we go. How's that? Oh, that glare is hideous, isn't it? Let's see if I can at least move some of that. Let's see. What do you think, you all? So here, yeah. So again, as we're talking about a number line, this side's always, the left's always going to be negative, and this side's going to be positive. So another way you can consider adding and subtracting integers is moving along your number line. So let's just say that's 0. All right, what do I mean by moving along my number line? We know that this is 1, 2, 3, 4, 5. This is -1, -2, -3, -4, -5. Let's just say that we had 5 minus, let's say 5 minus 8 minus 1 plus 7. Let's just say that was our thing. With this 5 being positive, that means we would start at positive 5. And minus 8 means that we go left 8. 1, 2, 3, 4, 5, 6, 7, 8. Putting us at -3. And then we go left 1 more, putting us at -4. And then we go right 7. 1, 2, 3, 4, 5, 6, 7. Putting us at +3. Right? Does that make a little bit more sense for you guys, moving back and forth along the number line? 5 minus 8, we know that would be -3, minus 1 plus 7, that would be -4, plus 7, and that would be 3. So we still get the same answer either way you do it, but I always have preferred to consider my addition and subtraction of integers as moving back and forth across the number line. So wherever I start, that's my starting point. If it's negative, I go left. If it's positive, I go right. The only situation we haven't really talked about is when you have 5 minus -8. Again, you cannot have two signs together, right? You're subtracting a negative value. Subtracting a negative value is the same as adding a value. Subtracting a negative value is the same as adding that value. 5 subtracted a -8. Well, if I'm subtracting a -8, that means I'm taking that -8 away. It's backwards, I know. But you will see this a lot of times, and you will just have to know. I mean, there's more explanation. I'm not going to get too heavy into it because this is just a video I'm making for you guys. If you do want more information, like I said, feel free to comment after I post this. But just know when you have two signs together like that, two negative signs, 99.99% of the time it's going to be positive, okay? If it's not 100, I'm pretty sure it's 100% of the time, but this is math, so I don't ever want, So, but again, adding and subtracting could be like moving along your number line, right? So back to our final answer over here. We know that we started at -14, right? And then we would go left 4 more spaces. That would give us, oh, that's my marker, I'll put that up there. That's going to be -18 plus 25. And now we have two values and their signs are different. And when the signs are different like that, can y'all see my 2, 5? Something like that, huh? Anywho, when signs are different, we're going to subtract our values and apply the sign of the largest number. 25 is bigger than 18. What is 18 minus 25, by the way? Anybody? You're correct. To 7, and our answer will be positive. Okay? So, hey, I'm going to go ahead and conclude this video because I did not know it was going to be about an hour, but I guess classes usually are about an hour, right? So let me know what you think. Should I spend time editing or should I find a better spot? I'm telling y'all though, I'm pretty lazy, and if I have to do all that, I doubt I continue making a lot of videos. Just kidding. But let me know. Hopefully it's helpful for you, and I will see y'all again soon with the next section. All right, take care.